Hi all, myself Dr. Hazari Naresh, Assistant Professor in Mechanical Engineering Department in VJEC. So to continuation our topic, we are going to discussing kinematics of machine subject, and today's topic is mechanisms, machines and degrees of freedom. Here we are going to discuss about what is machines, mechanisms, degrees of freedom, what are different criteria like Kuchibak criteria, Grubler criteria, and what are few simple problems. Those things we are going to discuss today. Next, mechanism. What is this mechanism? So when one of the link in a kinematic chain is fixed, one of link in kinematic chain is fixed, this is called as a mechanism. How? For example, see, let's say 4-bar mechanism, link 1, link 2, link 2, link 3, link 4, where link 1 is fixed. Then this is called as a mechanism. For example, the chain is known as a mechanism. It may be used to transmitting or transferring motion. Engine, indicator, typewriter, belt and chain drive. Okay, if you consider belt and chain, for example, chain. Four links, link 1, link 2, link 3, link 4, where this link or this distance is fixed. So we call as a mechanism. Next, when one of the link in mechanism kinematic chain is fixed, the chain is known as mechanism. It may be used for transmitting motion, same. So printing machine, everything same. So mechanism may be regarded as machine in which each part is reduced to a simplest form to transmit the required motion. So here, if you are going to give some input, some kind of output is produced. It's called as a mechanism. Next, machine. It is simple. When a mechanism is required to transmit power or to do some particular type of work, okay, where human effort is reduced, like machines, it becomes a machine. Like car, we are going to reduce our effort, just we are going to drive the car. It's a machine. Robot, it's a machine. So examples, so the various machines are there. So various links or elements have to be designed to withstand the force, both static and kinematic, safely. Machines. So workshop machines, automobiles, space, household appliances, marine ships, earthmoving equipments, or there are some n number of mechanisms are connected, then it becomes a machines. For example, bike, there are China spokes, it's one mechanism, and wheel and hub assembly, it's one mechanism, and steering, it's one mechanism, and engine, this is a mechanism. There are n number of mechanisms are connected, then it becomes a machines. Here, the difference between mechanism and machines. So if one of the link in chain is fixed, you get the mechanism. It is a collection of one or more mechanisms to do some desired work. It's called as a machine. Used to transmit or transform the motion from rotary to linear, transmit motion, transmit or transform energy into useful work. Okay. Every mechanism is not machine, but every machine is a collection of mechanisms. N number of mechanisms are there, then it becomes a machine. Then clock, locks, typewriters, and keyboard of computer, the examples are there. Next, IC, it's completely IC engine. There's a combination of n number of mechanisms, then it becomes a machine. Shaping machine, hand pump, these are the machines. Next, here the important thing is the degree of freedom. There are different pairs are there, joints are there, these are moving one related to the another. Then the important thing is we are going to study about the degree of freedom. So the degree of freedom, simply we can know that if an object, for example, If an object is there, this object I am going to live in space, consists of 6 degrees of freedom. It tries to rotate in its own way. So there's nothing but it's having 6 degrees of freedom. Here the degrees of freedom is defined as the number of input parameters which must be independently controlled in order to bring the mechanism into useful engineering purpose. It's called as a degree of freedom. So we are going to control, we are going to restrict the motion. So like steering gear mechanism, steering, if you are going to move left turn, then a tire moves left. Why can't it move right? Well, because we are going to restrict the motion. There is a 1 degree of freedom that we are going to allot it further. And the wheel is rolling on the road surface. Now the wheel is connected to the axle. Wheel is rolling on the axle. So it is the only turning motion is restricted. There is a 1 degree of freedom. So it is possible to determine the number of degree of freedom of a mechanism directly from the number of links and types of joints which it includes. So if every machine which used to produce some degree of freedom, that is going to form with the help of number of mechanisms. If we are going to restrict the mechanism, we can restrict the number of degrees of freedom. So here next, that few criteria are there to find the degrees of freedom. So first one is Kurzbach criteria for determining the number of degree of freedom or movability n of a plane mechanism. Okay, let us consider any mechanism. So here let us first discuss what is formula. Here consider n is equal to number of degrees of freedom, where L is equal to number of links connected, J is equal to number of binary joints or lower pace, specifically binary joints. Okay, I sing 1 degree of freedom, and H is equal to higher pace which is having 2 degrees of freedom. We are going to do with the help of H, where N is equal to 3L minus 1 minus 2J minus H, where N is equal to degrees of freedom, links, number of binary joints, number of higher pace. Okay, next, if there are no 2 degrees of freedom pairs, means H is equal to 0, higher pairs or 0, then substitute H is equal to 0 in equation. N is equal to 3L minus 1 minus 2J. Next, the Grubler criteria. It says that the Grubler criteria applies to mechanisms with only 1 degree of freedom joints, where overall movability of the mechanism is unity, it's 1. So the mechanism should be produce 1 degrees of freedom. That only says that Grubler's criteria. Substituting N is equal to 1, H is equal to 0, where in Kurzbach equation. Then 1 is equal to 3L minus 1 minus 2J. This is called as a Grubler's criteria, where Kurzbach criteria gives 2 degrees of freedom, 3 degrees of freedom, but this Grubler criteria restricts to 1 degree of freedom, which is applicable for plane mechanisms. Now, for example, here there are few cases. So 3-bar mechanism is seeing itself, it is fixed or it's locked. While you are substituting this, N is equal to 3L minus 1 minus 2J, where N is equal to 0. So 0 degrees of freedom. 0 degrees of freedom. It's a locked child. If you consider 4-bar mechanism, 3L minus 1 minus 2J, where N is equal to 1. Mechanism is 4 binary joint, 4 links, 4 binary joints. L is equal to 4, J is equal to 4. Link 1, link 2, link 3, link 4. 1 joint, 2 joint, 3 joint, 4 joint. Where N is equal to 1, it is a 4-bar mechanism, where you are going to give some input here, rotation motion, it produced output is restricted, is a constraint motion. Next, if you consider third case, like 5 links, L is equal to 5, J is equal to 5, then n is equal to 2 degrees, means 2 degrees of freedoms are produced. If you are going to rotate in this direction, then what will happen? Here one output, here one output. It is a not constrained. It's not completely constrained. It is an incompletely constrained motion. Like we have discussed, circular bar in circular shaft. It's an incompletely constrained motion. Most cases we are not going to use here mechanisms. Next, fourth cases where links is 5, joints are 6. Now you substitute here n is equal to 6. It's completely 0 degrees of freedom. Now fifth, again if you consider this, it is the mechanism shown is E 6 bar mechanism having 6 links, 8 binary joints, L is equal to 6, J is equal to 8. It is in terms of -8. It is a negative degrees of freedom. Okay, it will not move. Now, so where n is equal to 0, this condition A and D, for example, when mechanism forms structure, no relative motion between link is possible. Okay, next, the mechanism can be driven by single input, where B, it is single input. It's driven by single input. Now in condition of C, when two separate inputs or motions are necessary to produce constrained motion for part is C. Why? Because if there is one rotation motion, the different outputs are produced. Means there are two inputs are required to produce one output. If there is one input is there, there two outputs are there. Then we are going to restrict with the help of two inputs. We are going to apply two inputs, then one output is produced. This part is this. When n is equal to -1 or less, then there are redundant constants in the chain and it forms statically indeterminate structure. Like this structure we called as a superstructures. A structure with negative degrees of freedom is known as superstructures. Like if you see examples, superstructure is indefined structures. It can move in different in different directions. For example, auto, here one structure is there. This is called as a superstructure. The degrees of freedom is -1. It's called as a superstructure. Okay. There are examples. Various degrees of freedom for different joints. For example, if you consider anyone, for example, let us consider hip. Hip is having 3 degrees of freedom. So it's a flexible, abundant and axial rotation. Okay, so here this is. If you consider ankle, flexible, okay, 1 degrees. Here few examples are there. For example, if you consider case 1. Now here number of links are 7. 1, 2, 3, 4, 5, 6 and overall structure is 7. 7 links. Joints are 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 joints. Higher pairs. This is higher pair. This is higher pair. Now number of degrees of freedom, F is equal to 3, L minus 1 minus 2J minus H. F is equal to 1. This is a 1 degree of freedom joint. Okay. For example, if you consider here, so number of links L is equal to 4. 1, 2, 3, 4. This is considered as a 1 link. Joints 4, 1, 2, 3, 4. These are the sliding joints. Okay, sliding, only 1 degree of freedom. H, higher pace, partially turning, partially sliding. No, it's only turning. So it's only sliding, not turning. So h is equal to 0. Again, it's a f is equal to 1. Let's see here. Here same you can find degree of freedom. L is equal to 4. 1, 2, 3, 4. Okay. H is equal to 1. H is equal to 1. Okay. Then you can find degrees of freedom 2. There's a partial turning. Partial turning is, that's a 2 degrees of freedom. Here L is equal to 7, J is equal to 10, H is equal to 0. So there is no higher pace. So here degrees of freedom is 1. It's for folding stairs, those mechanisms we can use. Even if you consider stretcher, there are n number of links, n number of joints. That's the best example to study the mechanism stretcher. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.